10 seconds of introduction. This is my esteemed colleague and friend, Peter Norvig. As you can see, we wear matching Aloha shirts. This is a conscious choice. It's not an accident. In any case, he's literally written the book on AI, and he's an incredibly skilled and deep thinker about programming in general. And since he's got this AI background and this deep programming background, he's the perfect person to talk to us today about how AI systems can write code. Okay, so Peter, without any further ado, I'm going to let you take over here. Okay. I'm going to minimize my view here so I don't look so.
Hello there.
Okay, there's Peter. Take it away, Peter. More students will filter in as you talk. Don't worry about it.
All right. Good morning, everybody. Good to talk with you. So Dan asked me to talk about AI and coding. It's a fascinating topic I've been looking at for many years, and it's changing very rapidly. And I was looking over what we talked about last year, and a lot has changed since then, and some of it's still the same. And I also think it's an interesting problem because it really covers kind of everything that appears in the AI project lifecycle. So if you said, what do I want to do to deal with programming and AI, it covers basically everything that you'd want to do if you wanted to do anything with AI. All the issues and problems you can see within this one topic. So what are they? So I usually think of it as the first thing you do when you want to solve a problem is figure out, is there an appropriate technical approach? And with AI, usually involves some kind of machine learning. And what kind of data can be used? And here it seems kind of promising that there are a lot of programs out there on GitHub or whatever, and there's it's great that you can do simulations of these programs. You can actually run them. So the data seems very appropriate. Can we combine some semantic rules in deep learning? That's really interesting, right? So the reason we built large language models for English and other natural languages is because we didn't understand how English worked. And after decades of linguists trying to solve that problem, it didn't work. And so we did it through machine learning. In other areas, like in chemistry, we know something about the fields, and the AI solutions tend to combine deep learning from data and semantics. Programming is maybe at the extreme end, that we know exactly how it works because we built the compilers, so we know how they work, and we should be able to take more advantage of that. And yet it seems like most of the progress that has been made has been done through the deep learning and not the semantic rules. That's interesting. What if technology is not mature enough for full automation? You can't just say, I don't need any programmers anymore, the computer's going to do it all. We're partially part of the way there, similar to how we are, say, in self-driving cars, where we can do some of the automation, but not all of the automation. In that case, what kind of user interface makes sense? What's the role of the human in the loop? Do we take our existing programmers and just have them do better? Do we have a different class of human doing different classes of things? Will it be brand new tools and processes, or are we just going to augment the existing ones and make them better? How do we build trust? When you ask your AI to write a program, how do you communicate with the user what it is that it did, and does it have the right answer? So these are all questions for dealing with programming with AI, and they're the same questions you should ask to try to do anything with AI. Another example, how to combat vigilance fatigue. If 20 times in a row it gets the right answer to your programs without checking them, do you then just start accepting them and running the programs as is without checking them? What data can we use? And what about all the privacy and security and intellectual property rights? If I'm using somebody else's program, do I have the rights to use that? These are all issues for this problem and for elsewhere. Now, so what level of automation is the technology currently at? And I don't know if Dan showed you this earlier in the class. Yeah, you've seen this. So this is Society of Automation Engineers. They have this notion of these 5 levels. I think it makes sense to think about that. So level 0 would be no automation, which would be good old-fashioned programming. But I note that even the simplest programming languages we have are in some sense automated. We're no longer just flipping switches on or wiring up computers by ourselves. We have some automation. In fact, the first popular programming language, Fortran, was what's called an automatic coding system. Then level 1, can we do one task at a time? Maybe like code completion. Yeah, we're clearly there. Level 2, multiple tasks. Maybe think of a task like writing tests, but not doing the complete software process. Yes, it's clear that we're definitely at that level 2. Then level 3, it's a little bit less clear. Last year I said no. This year maybe I'm willing to say yes, that there are some tasks for which you can get a complete solution from a prompt, and there are other tasks in which you can't do that. And then level 4, which for self-driving was driverless in specific situations. I don't think we're there yet, where we can say, even within a limited situation, that an automated system will always get the program right. But maybe in something very specific, like database queries, or in something where we have a better means to test, say, optimize a program to make it faster after it's already been written. Maybe they could do tasks like that, and maybe count those as specific situations. Clearly, we're not at full automation yet. So I want you to take some time, turn and talk to your neighbor. And given all that, given we're at this funny state where we can do some things, but not everything, if you were the product manager for your company and say, we want to have an AI writing code product that will help somebody do something, what would you do? Who are the users? And what's a good use case? Something that could be useful, could be done in the near term, is not just solve the whole problem and do all programming automatically. What makes sense to try to approach? And there's lots of possible answers to that. So think about that and discuss that for a few minutes.
In general, like you said, like there's a certain level we can it's going to have but what makes it goes for example, from the AI. So you don't know you hire
Yes, then our check price is like parts that you can probably really yeah, that's why
from research is able to invest in and being able to anticipate how this action is.
But I think it's like
Yeah, I think like that is one thing that I have been wondering. I found myself like some of the time needing to do like some automated tasks like copying files, modifying, doing some spreadsheets, so on, so maybe we can with the proper usage we can expand from the software developer with like people who need to do some repetitive tasks right now very customized their.
That's true.
Okay, let's hear what you guys talked about. It's very strange doing this over this conference because I could hear there was a lot of talk going on in the room and I couldn't understand a single word. But maybe we could hear from some of you of what ideas you had, and I don't know how well that's going to work through the mic.
I'll help point out people.
Okay.
Anybody want to volunteer? Oh, come on.
I mean, who are the users? It's us. And we already use, for example, Copilot or ChatGPT to generate code now. And we were talking about the kind of driverless or full automation, like code generation. And we talked about this like fear of like us being replaced, programming is being replaced completely, but then there's this cycle of then it generates such complicated code that then people cannot understand it and explain it, and what failure happens. So then we need humans again. Yeah, so that was the kind of discussion that we had about this.
Okay, that sounds good, and I think that is it's definitely a good place to start. Is sort of a small project done by one person or maybe 2 or 3 people. It seems like you can get a lot farther there than in, say, trying to go into a large company and do everything all at once. So that's good. Anybody else?
Okay, yes, you guys.
Yeah, we were thinking of a product that can automate tasks on your machine, on your computer. For example, if you want to put all PDF files from old subfolders that contain something together, and to automate things like that with natural language.
Mm-hmm. Yeah, I think that's great. I think there's a lot of opportunity for sort of non-programmers to have a better interaction with the machines, and I've seen a bunch of examples of that. I had a friend who's a biologist, and he said, you know, I'm not a programmer. I could pull data, put it into a spreadsheet, and make a chart and put it in my publication. But I couldn't do any more than that. And I had this data of bird migration. I always wanted to visualize it. I knew a real programmer could, but it was beyond me. And then I started interacting with ChatGPT, and I built this app. And I never would have had the confidence to try without the help from AI. And I've seen multiple examples like that. Anybody else?
Yeah, okay, we've got the third group here. Go.
So I gave the example of what Meta is using. So they're developing like an internal junior level programmer. So it's also very interesting for companies to just replace basic coders, and in the future even maybe senior coders and at the end they're probably going to be like one overlooking very smart person who just orchestrates the whole thing and just tests the whole thing.
Yeah, I think that's interesting. And there certainly are a bunch of tasks that can be delegated, and it's interesting how kind of the field of software engineering has changed. So if you go back, 20 years or so, IBM had this model of the chief programmer that said there was going to be sort of one person who was really in charge of the whole project and understood everything, but they wouldn't write any code. They would just write specifications, and things would flow down in this hierarchical structure from the top to the bottom. And the person who understood, the wisest person who understood all, would tell the others what to do, and they would implement it for them. And that kind of fell away, I think, over time, as we realized that put in too much sort of hierarchical structure, and everything was top down. You had to define everything ahead of time, and sometimes you just have to be more experimental. And so that kind of broke down. But maybe if the automation is in a faster loop, where it's, instead of saying, I'm going to specify this to a team of programmers and they're going to come back a month later, if it's instead, I'm going to talk with this AI and it's going to come back a minute later, maybe that changes things and brings back that kind of approach. Okay, well, were there any other who wanted to share?
If I may.
Chat, yeah.
So I have been thinking of another kind of code, which is like automation in protein discovery. That instead of like writing the software code, it is writing the DNA code that encode the protein. And in that settings, we have the benefits of being able to simulate the resulting protein and then test it output in the simulation world. So therefore, the full, maybe in that level, full automation may be possible. And then when I map it back to the real world programming, maybe the reasons that we don't have full automation yet is because we cannot capture the richness of the phenomena around the programming in the real world enough to be able to simulate it, so that we can fully automate it.
Yeah, I think that's really interesting, and sort of this boundary of what we understand and what we don't, right? So, in a previous job, I worked at NASA, and we're really good at simulating the solar system and rockets. We pretty much put them where we want most of the time, and a few of them crash, but for the most part, you get down to very precise predictions. And when the astronomers tell you there's going to be an eclipse at such and such a time 3 years from now, they're right down to the minute. That's pretty amazing. And we can't do that like with traffic. We can't say somebody's going to step out into the street at 4:15 p.m. 3 years from now, because people are harder to predict. And so there's sort of this mix of some things that we really have down really well, and then other things that there's uncertainty, and we only have partial models. And I think AI might be better at that. We're really good if we have the physics, we have these equations, and we have the law of universal gravitation, and F equals ma, and we can just carry out those calculations. But you can't do that for people. And I think there are other areas that are kind of in the middle, right? So there was some, I thought was really interesting work on using AI to control nuclear fusion. The idea, you got this really hot plasma in a ball, and it's inside a vessel, but the walls of the vessel wouldn't be enough to contain it. They would just melt. And so you need this magnetic force that kind of keeps the plasma centered inside the vessel. And the physicists write down equations for that. And they've been trying to say, now let's wrap a control problem that solves that physics equation. And then the AI took over, and it was doing kind of similar things. And then the AI would allow the plasma to split into two blobs and keep them both within the vessel. And the physicist said, no, you can't do that. We don't have an equation that matches that. You know, here's the differential equation. It doesn't allow for there to be two blobs. It only allows for there to be one. And the AI just said, "Oh, I don't care. I'm not restricted by equations. I just run it and it worked. And so I do more of what works." And I think, you know, as we get away from the really well understood precise things, there'll be more discoveries like that, where the AI will be able to say, I can step outside of a simple one-line equation and I can do something more complicated. So I think that's a great opportunity. All right, let's move on. So we've seen a lot of progress recently, you know, just in the last month or so. One study says large language models can outperform human programmers, so outperforms 85% of human programmers on simple tasks. Maybe not so much defining everything at the expert level, but at the junior programmer level, it does pretty well. Then this SWE Lancer I thought was interesting. So Mustafa Suleyman, one of the founders of DeepMind, says, you know, we used to have this Turing test. Can you act like a human? And instead, he said, let's have a financial test. Can you make $1 million? And that should be the measure of how successful you are. And so people put together this benchmark where they went on these freelancer sites and said, here's a task, here's the definition of the task, and it pays $100 or whatever it pays. And then they put together this benchmark and you run programs against it. And there's like $1 million in payouts, and some of the programs are solving like half of those tasks. So they're kind of halfway there, or 60% or something like that, of being able to haul in all that money. So we're definitely making progress. That a year ago, we would be less than half of where these programs are now. And so in terms of what are the smaller tasks, I think there's a lot of things besides just writing the complete program. So one thing is saying, what's actually in my existing code base? Are there idioms? You know, does my API make it too complicated to do some things? And should I refactor it to fit what people are actually doing? Is there duplication that should be eliminated? Simple things like, can we get the indentation and so on right? We can do some of that with automatic tools without AI, but the AI can probably do better. Then a lot of people have focused on test writing as a possibility, because programmers tend to not like doing that, but AIs are good at it. Similarly, a lot of programmers don't like writing documentation, and so maybe you can do that. Code review is another task that's time consuming for a human and could be done, and so on. So a lot of possibilities for different tasks within the whole field. Now, we've been doing this for a long time in terms of trying to aid programmers, and one of the simplest things is just code completion. And in the classic models, like we saw in Visual Studio for decades now, it's just kind of, what are the, you know, you've typed a couple characters, what are the possible completions? What's the most likely next one? And so that's pretty simple. I've been doing that for a long time. Now we're trying to expand that to not just say, what's the next method to call, but what more can I do beyond that? And so the deep learning systems can do a better job of this type of completion. So one way to do it is through re-ranking, is that you can take an existing system, have it come up with its suggestions, and then use the deep learning to maybe make the best suggestions. You can, one of the great things about programs is we understand what the syntax is, so you can actually run that through the compiler and see, does it make sense or not? And I think one of the really interesting questions is, how do we build this product to be usable? And, you know, you've seen a lot of these language models, and you type in a prompt and it starts spitting out some output, but it can take a minute to come up with its answer. And if you're trying to be in the flow of programming, you don't have a minute. You've got 100 milliseconds. If it takes more than 100 milliseconds, you've lost the flow. So yeah, there can be a lot of tasks where you say, I'm willing to take a break now. Maybe I'll go get a coffee and, you know, have the AI think about it for a couple minutes. But there's other ones where you want that interaction to be really, really fast. And I think figuring that out and figuring out where the state of the art is and what can we do in those 100 milliseconds to help the programmer without slowing them down. I think that's really interesting. And it is a question of what the AI can do, but it's really more a question of what the user interface and human factors can do. And then there's this question of continuity of how much you're going to change. You know, programmers that are more senior have been skilled, and they've been doing this for a long time. They've got a flow. They understand the code base they've been working on. Can you fit into all of that? And both in terms of what their day-to-day work is, and then also in terms of the kinds of suggestions you make, right? So it's easy for a program, you know, you give a prompt, say, how do I solve this program? And it comes up with a 20-page solution, and then you change one word in the prompt. You don't want it to come up with 20 entirely new pages. You want it to say, how can I fit into what we already have and make a minimal change? Okay, so to what extent can these things write code? And I always like this quote from Edgar Dijkstra, one of the most famous computer scientists, who more than a couple decades ago said, in the discrete world of computing, there's no meaningful metric in which small changes and small effects go hand in hand, and there never will be. And so what did he mean by that? He says, well, you know, in sort of regular math and sciences, we're used to continuous functions. And, you know, you got some kind of a curve, and maybe it's a sine wave, or maybe it's an exponential, but you make a small change to X and you get a small change in Y. And there's a derivative that tells you how much. And he says, computing is not like that at all. You change one bit in your program, and it can have a completely different effect. And so therefore, there's nothing you can do to sort of understand what those small changes will be. And therefore, if you want to do gradient descent over a program, it's doomed to failure. So that was Dijkstra's conclusion, kind of well-reasoned. Science fiction author Arthur C. Clarke says, when a distinguished elderly scientist says something is possible, he's almost certainly right. When he says it's impossible, he's very probably wrong. And I think in this case, Dijkstra, in fact, was wrong. And Ken Thompson, one of the inventors of Unix, said it best, when in doubt, use brute force. And we've just got this computing power now. And maybe if Dijkstra had seen all the power we had, he would have changed his mind. But we can now do these things that, yes, it does seem impossible to say you can do gradient descent on something where one small change to one bit could change everything. But on the other hand, most of the time, one small bit change doesn't change everything. And so it turns out that it actually works. So just do the simplest thing possible, and in most cases, it works. So we use these pre-trained LLMs. We didn't even try to specialize them that much to the programming task. We just took a regular LLM that worked for English and said, now we're going to throw in some programming code. And how well does it work? A lot of variation, and maybe I should have put these on a timeline, because it does seem like it's getting a lot better. So here's the 2022 study that says, yeah, it kind of works. You get 5 or 10% improvement in a programmer's time. Then in 2023, there's a 40% improvement. In 2025, 57% improvement. Developers also say that they're happy, that they like using these tools. They don't feel threatened or replaced by them. They should say, my job's easier and more fun if I have these AI tools on my side. However, there was this 2024 study that says there's more bugs in the code page. So I guess what that says is the programmers are working faster and they're not being as careful. So that's something to watch out for. And in general, it feels like you're building up this technical debt. And maybe that's true anytime that you move faster and you're not making sort of long-term plans, but you're just going with the flow. you tend to build up things that have to be corrected later. Here's an example. You've probably all seen this. Many of you, it sounds like you've all done this yourselves. So I say, make a website for a student who's looking for a job, and it codes up the HTML and the CSS. So how does it work? There's a great paper and open source code from Andrej Karpathy in which he builds this neural net and feeds it in some text and sees what it does, and then tries to sort of decipher some of the hidden units in the neural net and what do they do. And some of them, no one has any idea. So here's one, and it lights up red for some of the letters and doesn't light up as much for the others. No one understands what that particular hidden unit is doing. Other ones do make sense. So here's one that seems to understand what's code and what's comments. So it turns on inside comments and quotes where the syntax of the language is no longer being followed. So we didn't have to tell it, that there's a formal rule for this is the characters that start and end a comment, but it figured it out. Here's another one that activates inside if statements. And here's one that seems to be sensitive to the depth of the expression, that as we indent one bracket more, it turns on more and more. One that predicts a new line. So how can they understand programs? So we started out by just saying, we'll just use the technology we built for natural language and just feed it in as text, and we can certainly do that. We can also feed in the output of the compiler, essentially the abstract syntax tree or the assembly language code. We could give it traces of the execution flow, so it actually understands what's happening when the program's running rather than just the static text. We could give it the whole revision history and issue database, right? So every check-in to the project, we could give it. And that'd be useful, because then it seems like you should be able to have a tool that says, yeah, if you have this line here, that's correct. It's not an error. But when people write code like that, they usually end up, there's a bug filed against it and they change it later. So maybe you don't want to do that. And you can't do that from the text itself. You have to have this history of check-ins. And I know at Google, we've been doing keystroke by keystroke logging. So we have a lot of very detailed history of what programmers do. And that data can be useful for this. And then also, you've got this technology that reads language, so you can read the comments and the design docs in natural language. And that seems really helpful. And then here's just a chart of how all these things flow together, and don't take anything out of that other than that. It's complicated, and there's a lot of things you can look at. So this is from February 2nd. Andrej Karpathy is, I don't know if he coined it himself or just popularized this idea of vibe coding, where he says you forget that the code even exists. You're just having this conversation with the language model in the way that you would with an assistant who's programming for you. And he says, I'm lazy and I usually accept all to the suggestions that it makes. And he gets good results with that. I gotta say, I don't think that means that anybody can get good results. I think part of the reason he gets good results is that he really knew what he wanted to do and he could have done it himself. And that means he's really good at describing what it is he wants in the prompt, because he knows what he wants to build and he knows basically how he would have built it. So the descriptions in the prompts are good. And he says he usually accepts all, but sometimes he doesn't, because he really understands what the code should look like. And when it's getting off track, he can very quickly get it back. So if you're an expert programmer, then you can be successful in this kind of approach. If you're less expert, I think it's going to be more hit and miss. So these code generators are really good at well-known tasks. So I said, write a Python program to solve the set cover problem, a well-known computer algorithm, and yeah, the answer is fine. And then I said, make the subsets have weights, right? So part of it is choose a subset that has a minimal number of elements, and now let's say each element has a weight associated with it, and choose a subset that has the lowest total weight, and it says, yeah, I can do that too. And it's nice that it's pretty consistent, that it makes sort of the minimal amount of change you needed to add in that feature. Then I said, make it more efficient. Here it didn't do a great job. So one thing it did is try to choose the best first rather than choose a random one first. But it does that by every time through the loop, sorting all the elements and then taking the maximum member. And you could do a lot better than that, right? You don't have to sort them all. You could keep a priority queue or something and just pick them off one at a time. So that wasn't great. And then I said, what if the subsets had names associated with them? It's just sort of a bookkeeping thing, and it does pretty well at that. So I did feel like, you know, at no point is it doing something I couldn't have done just as easily, but there are multiple steps, and it's kind of keeping up as I'm going along. And I think that's pretty indicative of how it usually goes if you're dealing with something that it's seen before multiple times and it kind of understands where you're going. Here's one where I wanted to test the limits and say, what about something that it probably hasn't seen before? And there's a lot of talks of, do language models have a theory of mind? That is, do they understand what other people are thinking about and what people are thinking about, what they're thinking about, and so on. And I noticed that a lot of kind of logic puzzles that can be solved with mathematics or with programs have that kind of approach, you know. So person A says something, and then person B says, I don't know the answer, and then person A says, oh, because you said you didn't know, now I know the answer. And one of those types of puzzles was called the Cheryl's birthday problem, where Cheryl tortures her two friends, Albert and Bernard, by telling one the month of her birthday and the other the date of her birthday, and then having them guess. And so I asked 9 different LLMs to solve this problem, and I asked them to solve it either with just give me the answer or with writing a program to do it. And of course, they were all familiar with the problem, so they could quote verbatim the answer. But when I changed the data for the problem to use different numbers, they all got it wrong. And when I asked them to write a program, they all very confidently wrote a program. Here's Gemini and ChatGPT, but all the other ones have the same problem. They all very confidently wrote a program that tried to solve the problem from one point of view and never considered each character's point of view of the other character's point of view. And so they all got it wrong. So that was disappointing. And maybe the most disappointing thing is they never said, oh, gee, this is tricky, or I don't know. They just said, here's the answer. So if you know, and I got to admit, this is kind of an unusual type of problem, and they probably haven't seen many like this before. But if you're dealing with things like that, results are not going to be as good as we've seen in the other studies. Sometimes things are better at programming than just math. So my friend Weiwa had this problem, list all the ways in which 3 distinct positive integers have a product of 108. And you see the answer there is these 3 subsets of 8 integers. And so again, I went to a bunch of different LLMs and first asked them the problem just as it was stated, list all the ways, and then asked them to write a program to do that. And interestingly, when you asked it to list all ways, only 2 out of the 9 got the right answers. And when you asked it to write a program, 7 out of the 9 did. And why is that? So here's part of what was going wrong. So all of them seem to be good at saying, all right, first thing I got to do is figure out what's the prime factorization of 108. It's 2 times 2 times 3 times 3 times 3. And then they all know, now I have to divide those up into 3 subsets, and then I'll have 3 numbers. Some of them got confused, and they kind of forgot that the subsets have to be different. And so they had duplicates of the number. They had, 2 times 2 times 27, but that doesn't count because they're supposed to be distinct. And then some of them, because when you write the prime factorization of 108, you don't write down 1. Some of them forgot that 1 is a factor of 108, or equivalently, they forgot that the empty set is a valid set when you're dealing with factors. And so they left out the answers that had the number 1 in it. But when I asked them to write a program, so I guess it's kind of understandable. It's easy, or 1 is kind of weird. It's when you deal with it's not a prime, it's not a prime, so it's easy to get confused and leave out 1 when you're dealing with math. But when you're writing a program, you wouldn't write for I equals 2 to n. You write for I equals 1 to n, and so they all got it right when they're trying to write the program. So I think that's interesting, and what it says to me is we have these different languages. There's these languages of programming, and there's languages of mathematics, the language of chemistry came up, and so on, and they're good for solving specific problems. And we should try to make our systems use the appropriate language at the appropriate time. And sometimes when they don't, they perform worse. So here's an example, this is now a couple of years old, of OpenAI's Codex system, which was designed to solve math problems, but it did it by using Python programs as an intermediary. And I think that's a good approach for a couple reasons. One is you can get feedback, so they can have the system write the program, run it, see if the answer makes sense at all. They can vote, right? So they could write 10 different programs, run them all, and if 7 of them get the same answer, then that gives you more confidence that that's the right answer. But you can't do that if it was just writing, English or LaTeX and just having text. You can't run the text the way you can run a program, so you can't get that kind of feedback. And so I think that's one of the advantages of using a programming language in the loop. A lot of the big companies now have been entering programming contests with their systems. DeepMind's AlphaCode was one of the first to do that. This was their prime example of code to solve this problem. I won't read it all there, but I'll try to explain it. It's called the backspace problem. So you're given 2 strings, S and T, and you're asking, can I type the string T by typing the letters in S, except that some of the letters you're allowed to replace with a backspace, and you get the choice to do that. So I'm given ABABA, and my goal is to produce BA. And one way to do that is to replace the first 3 letters with backspace, and then type the BA. So that gives me the right answer. And here's the program to do that. And it's correct. Seems like a reasonable program. But I said, before I allow somebody to check in that program, I'd want to do a code review. And here's the things I came up with. And there's a lot of stuff there, right? And maybe that's not surprising. And, it was trained on code in GitHub, and half the programmers there were below average. So maybe it's not surprising that it does a lot of things wrong, but there's a bunch of stuff that's kind of weird in there, right? So in the middle there, in the big green box in the middle, there's a C equals empty list to initialize it, and then inside the loop, they're popping an element off of stack B and appending it to list C. That seems like something that you often want to do when you pop something off a stack. You often want to put it somewhere, and then C is never used anywhere else in the program, right? And I've seen programmers that do things like that, and I don't want them to work for me, and I don't want them to be checking code into my code base, right? But I think what happened here is it just said, yeah, I've seen a lot of training examples where I'm dealing with stacks and I'm popping things off and I'm saving them somewhere, so I'm just going to do that. And then it never went back and figured out what it did wrong. And then there's lots of other things like that. So again, this was a couple of years ago, and now I think the models are much better at using more runtime resources, and so doing more thinking and reflection. So maybe they'd be better at cleaning this up, but it's still, they got a long way to go. And this was an interesting part. You can look up that paper, and here, sort of at each point, they kind of highlight what they're looking at when they're making the next choice. So I think that's kind of interesting. That sort of, they say, you know, so I'm in a while loop here now, and so these are the tokens that I'm likely to put up next. What I'd like to see is, you know, here's the program I would have written, and it's a lot shorter and simpler and better documented. So should be able to come up with something like that. And I want someone to write all these test cases, right? So that is a kind of a boring part. I would have rather not have written all that. I wanted to write that for me. Then I want to do something like saying, you know, am I really sure that this is correct? You know, this was an order n algorithm. Give me the exponentially slow algorithm and show that that's correct. Show that it gets the same answer as mine, and show that there's a transformation from this slow but obviously correct program to the more efficient program. And those are the kinds of things you sort of think about when you're programming. But if you had this assistant that just could act really fast, I think we would do more of that. To, you know, show me the equivalence between these two, show me the transformation between them, compare them to each other, right? I could do that, but it would take me too much time. But if the assistant does it for me, I think it's really useful. And then I want something that I can do pair programming with, that I can have these kinds of conversations and all this way of talking. And, you know, here's something I was worried about in this program. Can you convince me that this is right? And have that kind of conversation. Now, so the next thing is, if I'm going to train this on code that's out there, what's going on with that? And so we're seeing this with text, we're seeing this with images, we're seeing this with songs. What do you have rights to? And so GitHub faces this lawsuit. And anytime you're training on this data, you have to be able to figure that out. So let's take another couple minutes and just think about this. So what should be legal versus illegal, and or just maybe it's legal, but you shouldn't do it because it's bad or it's against the norms. So can you read public source code? Is it okay to learn a model from that? Is it okay to store an exact copy of the code? Is it okay to generate code that learned from that code? Is it okay to generate an exact copy rather than something that's just similar? Where should the boundaries be? So discuss that with your neighbors for a couple minutes.
What do you think? Anyway, this is
by default, if there is no license, this is one that I can talk about. Either
Everyone who starts using AI
cannot be copyrighted.
those websites like they're also used for LLM training. So there's less sense so you see what like the coding technology stuff, gets to the application, but coding gets so it's very less of those data variables
without reading it. Without storing it. Yeah.
It's almost a little less.
Like,
Continue training.
it is possible to learn without but read that code and then translate into some sort of way or some parameters that they will do. They will store the exact copy of the code, but store vectorize the
So that's what I'm.
No, there was
I mean, that's
still
how much I would say that the actual code for the
my teacher reaction is like lying with you that whatever human can do legally, I think they will sure. But then when I take a step back,
Okay, I don't want to spend too much time on this.
very fast.
Do we have any conclusions? What's the boundary of what you should be allowed to do with this online code?
Anyone have thoughts? I'm sure you can. Oh, yeah, go for it. Sorry.
Yeah, we said that all of these are legal, but the problem is that those LLM models are trained with the data from websites like Stack Overflow, let's say. And if less people are giving their input and advancing the coding and technology, then the future models of LLMs are getting less trained. They have less data to be trained with, right? Because people are just using the code from the LLM models.
Yeah, okay. So one thing would be say, yeah, this is okay. And I think legally that's right. Another would be to say it's important to sort of foster good communities now and in the future, and think about, am I sort of sabotaging a community by cutting things out? I think that's a good consideration. I think another consideration is being careful about accidentally picking something up that somebody else pirated. So, it's easy enough to go on GitHub and say, let's look at the license for this project. This license says I'm allowed to read it. This other license says I'm not. Okay, I won't read it. But what if somebody else picks up that project and reposts it and strips off the license? I think you should have a duty to do a little bit of due diligence to try to make sure that you don't do that, of picking up something that was pirated by somebody else. So that's another consideration. Okay. And then I guess coming to the end, but I think it's really interesting to see, where are we going to end up? So what's the future of software? And these are two books I thought were interesting. Neither of them are really explicitly about using language models for coding, but they both discuss the future. And so this, and I kind of think of it as it's going to be more focused on human-computer interfaces and sort of this partnership of what does the automation do and what does the human do. I think there's going to be more flexibility. We're going to have an ability to handle more open-ended problems, and more people are going to be able to do that. More sort of less expert programmers, and maybe more domain experts are going to be involved more in specifying their solutions. I think we're going to be less worried with proofs and more with just making something that's useful, in part because that's what these tools are better at, and also in part because I think we're going to change the types of problems that we address, right? So a lot of computer science was saying, well, our field is about the kinds of things that you can prove, right? So I can prove that this algorithm for sorting is a correct algorithm and that it runs in order n log n time. But I can't prove, that this, program for doing image recognition is going to correctly label every object in an image, because there is no ground truth for that. And there is no way to verify that it's always going to be right. And so I think we're going to be dealing with more of those types of problems because we have the technology to do it. So it's going to be more probabilistic rather than Boolean. I think it'll be more sort of descriptive rather than imperative. So it won't be first assign this to A, then assign this to B, then do this calculation, and then loop until this termination condition is true. It'll be more like, here's in general what I want you to do. And then programs will figure out how to do it. So in the Hansen and Sussman book, one thing they say is one should not have to modify a working program, one should be able to add to it. And, so a lot of what we do now is editing existing programs. And sometimes that's hard because if you don't have the source code and you only have the program to run, now you're cut out of that. And what they're suggesting is let's have a system where it's easy to add on to existing programs without editing them. Rather, you should be able to walk up to your program and say, no, I didn't like the way you did that. Hey, mapping program, I don't like going on the freeways. And from now on, do this other preference instead. And I shouldn't have to be able to go in and edit the code to do that. I should just be able to have a conversation with my system and add on my preferences, tell it what I want it to do differently. Then they also say biological systems use contextual signals that are informative rather than imperative. There's no master commander saying what each parts must do, right? So in a computer, there's a program counter and it executes an instruction and the computer just does the instruction. That's not true in your body, right? That's not true in a biological system. There's no one thing that's in charge of your whole system. Rather, it's every cell sort of communicating with every other one. And I think our software systems will become more flexible like that. They'll become more like the biological systems. And we don't quite know how to do that yet, but I think we're moving in that direction. And then Kevin Kelly says, all is flux, nothing is finished. That means processes are more important than products. So yeah, you could create a great product, but if your users can't change that and use it the way they want to use it and combine it with something else that doesn't exist now but will in the future, then you're going to be left behind. So you should be building systems that are more flexible and can do that. So why don't I stop there, and I guess we have some time for questions and discussion.
Very good. So can I start, Peter?
Yes.
First question, which is, a bunch of students here, they want to stay on top of this field. What would you recommend they do going forward to sort of help keep themselves educated and informed on developments in AI and system programming building?
Yeah, so it's tough to keep up because things are changing every day. So, I watch the various news feeds. I subscribe to some newsletters. I read papers when I have the time to do that, and just try to keep up that way. And then I guess, don't spend all your time reading. Spend some of your time doing that, but spend some of your time just going out and building stuff.
So build and explore. Okay, any questions from anybody else?
Maybe just
Let's go to it.
maybe just a small comment. I like the part that you mentioned using the programming language in the loop, and it makes me think of like nowadays to address the carbon problem, we try to electrify everything, but mapping it to the LLM world, it seems that you propose that if we want to build some system with LLM as a component in it, we need to languify it. So to use the properties of LLM, that it is very good in language, in like remembering the constraint of the language. So instead of having the problem that require working memory, require conceptualization, try to map those working memory conceptualization into the language constraint, and that will kind of like improve the accuracy. So I think that is the point that is like a very, very good insight from today.
Yeah, I think that's right. And I think, we have a lot of different languages. I'm interested in seeing where this goes, right? Because the programming languages we have are not native to language models, right? So we started out and we had assembly language, which was designed to get the most possible efficiency out of our hardware. And then we moved to, like C, which was a compromise between efficiency for the hardware and efficiency for the programmer. And then to Python, which was really much more focused on ease of use for the programmer and less on efficiency for the computer. But now we want a language that's focused on efficiency for the language model plus human pair. And what should that be like? And, and it's probably not going to be Python or Java or C. It's probably going to be some different language. And it's probably also not going to be just English by itself, but maybe it's going to be more English-like. And it'll be interesting to see over the coming years what kind of languages we come up with.
A question to your person: how was it to work at NASA?
It's really fun working at NASA. So I was there for 3 years. Then that was the most government I could take. There's kind of a little bit too much bureaucracy. And then I moved over to Google, and so they were at Google and NASA were at opposite ends in terms of bureaucracy, but maybe similar in that there were a lot of people there that were really great at what they did and were dedicated to the mission, and so enjoyed doing that. So let me tell you a NASA story. So I recently met up with a former colleague, and she was a PhD intern with me at NASA, and she now is head of robotics for the Mars program, Bandy Verma. And she says, I get to drive the rover and fly the helicopter on Mars. How cool is that? And the interesting thing is that the helicopter, which had a long career, much longer than it was expected before the rotors finally broke, in their design, normally when you send something into space, you use these old, slow processors because they're radiation hardened, because there are cosmic rays in space that can zap your program. So they start designing it and say, we can't fly a helicopter. We can't make decisions fast enough if we use these old chips. We're going to have to put in, a modern high-speed chip. And they say, okay, it's only supposed to last a nominal mission is a small number of days. It'll be okay if it gets fried. But it didn't, and it survived. And so not only was it a successful flight vehicle, it also became the supercomputer center for the entire planet, because it had the best processor around, right? So there's a couple of rovers going around, there's a couple of orbiters, and they've all got these old, slow computers on them. And then there's these GPUs sitting on the helicopter. And so, it seems like a scene out of one of these Andy Weir, The Martian books, where the orbiter would say, oh, I got some images. I could send them back to Earth, but that'll be slow. I think I'll ship them over to the helicopter first for some quick image processing, and then ship that back to Earth. So I thought that was kind of cool.
Go for it. And where do you think is the future of software engineers going, and what career path would you suggest us in this area?
Yeah, so, there is some worry about that. Are all these jobs going to disappear? I don't think so. I think there's going to be, if anything, probably more jobs. And maybe individual companies might have less, like the big software companies might be more efficient at what they do. But I think that means that everybody else is going to have more engineers, and companies that didn't previously, feel like this was in their range of specialty. Maybe an engineering company or something that says, well, we buy some software, but we wouldn't really do it ourselves. We just use the software to solve our problems. I think they're going to now say, well, it'd be much faster if we could create these programs ourselves. And I think they'll want programmers to do that. So I think the net will be a lot of wealth will be created. The speed will be faster, and so there'll be more opportunities for more people. But maybe it's, don't spend all your time reading Corman, Leeserson, and Rivest and learning, all the details of insertion in red-black trees. Instead, spend your time learning about some subject matter, right? So if you're interested in biology or chemistry or something, there'll be good jobs for someone who has that expertise in some area and also has programming skills. And then also focus on kind of communication, right? Because part of what you do will be speaking in English to these AI coding assistants, and part of what you do will be speaking in English to other people to try to understand what is it that we're trying to build. And we want to come up with an answer quickly. Got to understand the problem. We got to be able to communicate that to the machine.
I'm going to agree with you, Peter, and add a little my own color commentary on that. So I completely agree. There's still going to be software engineering in the future. It will be different. It will be different. You probably will not be writing lots of special characters with lots of parentheses, semicolons, equal signs. But people still need to know how to communicate complex concepts to the machine, some of which are computer sciencey concepts. So, for example, the notion of retrieval from a complex database, notion of a foreign key, you may not have to write that SQL code, but you needed to know that concept. So you can explain to the computer, I need you to write code that will take this data set and align them on this data fields. So you see what I'm saying? You need to have those computer sciencey concepts. And that's going to be the computer science jobs of the future. People understand both the domain, like Peter said, and the domain of complex data manipulation, the CS concept. Question in the front.
Follow-up question on that.
Okay, tell him. Or are you asking me?
All right. So if you're a junior developer, you use this stuff and you're just using LLMs, then you're not going to improve that much because you just copy and paste, and you're never going to switch. You're going to have to do hard research, going to Stack Overflow and try it, and you just kind of stuck. So that's what I'm worried about, that you don't make any progress anymore.
Yeah, so had a little bit of trouble with the sound, but I think the gist of it, as I understood, was maybe you're not going to get the training and experience that people got in earlier generations, and so there'll be, if everybody's kind of an amateur interacting with these tools, maybe it'll be harder to proceed past the amateur level into the skilled level. I guess there is an issue with that. And I think it'll be mixed. And I think there certainly will be some people that will say, I'm happy to be at that level. It's great. I don't have to know everything. Right. And, so maybe think of it as I can use a car, but I'm not an expert at being able to fix one and understanding everything that goes on inside the engine. And I'm perfectly happy with that. And I'm glad that there are other people who do understand how the engine works and can fix it when I need it. So maybe we'll need fewer of these people who really understand everything. But I guess we still have a need for having that education process, having everybody advance to the level where they're effective at what they need to do, and making sure that some of them advance to the level where they have this very deep understanding. And I guess I feel like there'll always be people who want to do that, who feel like, this is the thing that really excites me, and I want to know everything about it. I remember years ago, Don Knuth, who wrote this seminal book on computer algorithms, he says he thought, there's like 2% of people have this weird ability. And he kind of got misquoted as saying only 2% of people could be programmers. And I don't think he meant that. I think what he meant was only 2% of people were like him. in that they were obsessed with programming and wanted to spend their whole life doing it. And from that point of view, that seems about right. So sort of, anybody can learn to use these tools and do something with them, but only a small number are going to be obsessed with doing computer science the way Knuth does, or, doing music the way Mozart does, or whatever. And I think it's fine if we do that. And maybe we were kind of oversubscribed, and there are too many computer science majors, and maybe people did it because they said, well, it seems like I can get a really good job if I do that, and maybe there are more people doing it than naturally should compared to other fields. And I guess it's okay if we have fewer experts in the future. We need a certain number of them, and I think we'll get that number.
Go for it.
Hello.
You have to speak as loud as you can.
Okay. Okay, so my question is, when you started working on AI, did you think like AI would be a big boom? Now it is now.
Right. Yeah. So great question.
And what do you think? What lies ahead in like 10 years in future of AI?
Yeah. So I'm an AI hipster. I was doing it before it was cool.
Yeah.
I went to grad school in 1980, working on natural language understanding. And I guess I always thought that at some point in my career, I would have a natural conversation with a computer. I don't know if I knew exactly what year that would be, but I definitely didn't think it would turn out the way it did, right? So, I didn't think, oh, well, the way to do it is just to dump terabytes worth of data through this neural net and the answer will magically pop out, right? I thought it was going to be a lot more hard work. And I guess, and I think a lot of people felt this, right? So there was this, we sort of had this idea that, you're reading text and there's stuff on the page, and that's really important, and understanding that is important. But there's also stuff going on up here in my head to interpret what's going on the page. And I thought most of the work would be trying to duplicate what's going on up here. And it turns out that kind of just fell out magically without us understanding what goes on in the head, without us having to write down all the rules of grammar and so on. We just got that. And so I think that was a surprise to everyone. And I guess because I sort of felt like more of it was going to be built by hand rather than just everything learned, I also never imagined that we would have the breadth that we have now. So, one of the projects I worked on was understanding computer manuals. And so I said, at some point I'm going to have a very fluent back and forth conversation about how this computer works and, what all the Unix commands are or whatever. But I didn't think, you could also ask the same program about anything in the world and that it would be able to answer. That was way beyond what we ever thought would be possible. But here we are.
Okay. Any other last questions? Trust's got one more.
Yeah. I like that comment of yours makes me connect back to the student question about software engineering. And I think what you just mentioned indicates the importance of being able to go up and down the level of abstractions and being able to ask questions and evaluate the output for each of the level. This can be like kind of like new class of the software engineer that will be like equipped with the LLM or generative AI model. I have one question to in a different context though. Today you mentioned several systems that is powered by LLM. How about other AIs that are not LLM? Is it not in vogue anymore in the software and encoding projects, or is it still? Are there any development from non-LLM AI out there?
Yeah, so that's a good question, and certainly there are parts that are kind of built in that use other aspects of AI. So you think of like the DeepMind did the Go and chess playing programs, right? So the reason they were successful at beating the world champion is because of this deep learning. But I don't think they would be successful if they just said, we have a deep learning network and just go from there, right? So that would have played at the level of a good amateur, but it would not have been the world champion. So instead, they use this kind of traditional AI approach of using the Monte Carlo tree search. And so they put this structure in, and we called it AI. Maybe you could have just called it an algorithmic or a data structure that it was constrained to use. And so I think a lot of the problems be like that. I think you're also seeing that in so the protein folding approach and things like that, where we have knowledge from chemistry and maybe some knowledge from AI, and we build that in, and then we have the neural net on top of that to gain the flexibility.